When asked how old she was, Susie replied, "In 2 years I will be twice as old as I was 5 years ago." And how old is she? I'll let you think about that. I'll try to remember to give you the answer at the end. So this first part of this first video, I'm going to just have you work with your calculator and type in some polar functions and just to kind of get a feel for what a polar graph would look like. So if you don't want to see what polar graphs would look like, then you don't even need to watch this video. But it's kind of cool. You're going to see some new things and things you haven't seen before. And the first thing we want to do, notice at the top of this paper, now you don't have this paper, and that's okay. You don't even really need to take notes right now. I just want to show you so you can get a feel for what, like I said, what the polar graphs would look like. So again, the first thing we're going to do is, notice at the top here, you want to be in mode, polar, so you push the mode button, and the one thing you need to make sure you're in is in radians, and then just below the radian degree line, you have function, parametric, PAR, and then POL for polar, and that's the mode we want to be in. So as soon as you select that or highlight it, then push the enter key and you're good to go. So you're in radian mode and polar mode. And let's go ahead and go to format. Where's that? Second format. And it says axis off. So we want to go down there to axis off. And polar GC. Let's see what that does. Polar GC. We're going to highlight that and hit enter. Okay? So actually, I don't even know what that's going to do. So we'll see. So then when you're in polar mode and you go to the y equals, you'll notice that it doesn't have y1 equals anymore because that's function mode. Y is a function of x. Here, r is a function of theta. And so clear that r1. So let r1 equal 4 times the cosine of 64. And to push theta, notice that the independent variable key is the key that you usually push to get an x there. So if you look on that key, it's just to the right of the green key, x, t, theta, and n. When you're in polar mode and you push that button, up pops a theta. And you don't want to hit graph yet. You want to hit window, and let's adjust the viewing window. So the viewing window, x min would be 0, sorry, theta min would be 0. Theta max would be 39, and the theta step is going to be 0.1. So I'm just following what I see over here on the left-hand side. Okay, and then it says x min and x max. So we're going to go x min to be -6, x max to be +6, and x scale to be 0. The y min is going to be -4, y max 4, and y scale 0. And that's it. Now hit graph. And let's see what happens. Now, by the way, in the next video or one of the next couple videos, you're going to learn how to graph these polar functions. And that's a polar graph. So it's kind of cool. It'd be interesting to adjust the y equals. Instead of 64 theta, let's just go to, let's just delete this 6 and let's put 4 theta. Let's see what happens. Now let's think about this for a second. If you were to make an r theta chart and you started theta at 0, think about that. If theta were 0, what would r be equal to? You'd have 4 times the cosine of 0, which is 4 times 1, and so you'd have r is 4. Okay, well what would happen if theta were... No, I won't do this to you. Let's just see what happens. Graph. Interesting. So a little bit different. But 64 theta gave us a lot more circles, a lot more until we got all the way back around. And you can see it's still going. I don't know if you can see that or not, but it's getting thicker and thicker. It's still going. The reason why it's still going is because we had theta max at 39. If you had theta max to be, let's just change that. Let's change theta max to be 4. Okay. Let's see what happens. Graph. So that's what happens. It doesn't keep going. Theta max just keeps going. If you have a high theta max, it just keeps going. Let's try the next one. Okay. Let's go ahead and adjust. Oh, we had. Oh, that's the same thing I was doing. I was adjusting things a little bit, and we used the same function. Let's actually jump down to number. Let's see. Let's just jump down to number 3. You know what? This would be kind of cool. Let's try this. Again, I shouldn't have had you erase that. 3 times the cosine of 64 theta. And then we're going to adjust the window, though, from 0 to 2 pi. Okay. And the theta step would be pi divided by 24. You don't necessarily need to memorize this kind of stuff. X and Y is same, so go ahead and hit graph. See if you get the same thing I got. That's pretty wild looking. Okay, let's go back in. Y equals 4 times the cosine of 3 theta. Okay, and let's do R2, 4 times the sine of 3 theta. And then R3 is negative 4 times the sine of 3 theta. R4, 4 times the cosine of 6 theta. R5, 4 times the cosine of 3 times, what did I do? Oh, I didn't, I messed up on my R4. 4 times the cosine of 6 theta. R5, 4 times the cosine of 3 times the quantity, theta minus pi divided by 3. By the way, there was this one high school student who got credit for a particular name for a polar graph. So you can, this looks like somebody was experimenting with different polar graphs, and they came up with what you guys are going to be seeing here. So let's see, 0 to 2 pi. Yeah, so all the window should be the same as the last graph. And let's hit graph. There's 2, there's 3 graphs, there's 4, 4th graph, 5th graph. Actually, that was graph number 6, R6, because R6 equals 4. The R equals 4 is that circle that circles the whole thing. So that's kind of cool. You take a look. I'm going to do another video. If you want to see some more graphs, you can look at the second video. In the third video, I'm going to teach you how to actually draw the graphs by hand without a calculator. And why would you want to do that? Well, it's going to really help your understanding. So again, there'll be 3 videos tonight. One video, the first 2 videos will be just using your calculator to graph some pretty cool looking polar graphs. So, oh yeah, that's right, I was going to give you the answer to the riddle. The riddle was, when asked how old she was, Susie replied, in 2 years I'll be twice as old as I was 5 years ago. How old is she? Well, she is 12 years old. Susie is 12. I'll let you figure that out.